Hello everyone, my name is Anand Suthar and welcome back to our LeetCode problem solving series. Today we are solving construct binary tree from pre-order and in-order traversal. LeetCode problem number 105. This is classic tree construction problem that look tricky at first, but once you understand the pattern, it becomes really interactive. The good news, there is a symmetric recursive approach that works every time. Let me show you how. Here is the problem. We are given a two arrays, pre-order traversal and in-order traversal of a binary tree. We need to reconstruct the original tree. Let me remind you what this traversal means. Pre-order traversal visits nodes in this order: root, then left subtree, then right subtree. And in-order traversal visit node in this order: left subtree, then right subtree. For example, with this tree, the pre-order traversal is 3, 9, 20, 15, 6. Root first, then left, then right. And in order traversal is 9, 3, 15, 26. Left, then root, then right. Given just these two arrays, we need to build back the exact same tree. The key insight is that the first element in pre-order is always the root, and in-order tell is what goes in the left and the right subtree. Let me explain the approach. Here is the step-by-step strategy. In step 1, we create a map that stores each value's index in the in-order array. And in step 2, the first element in the pre-order is always the root of the current tree. And in step 3, find the root value in the in-order array using our map. And in step 4, everything to the left of the root in order belongs to the left subtree. Everything to the right belongs to the right subtree. And in step 5, the number of nodes in the left subtree equals root index minus in start. We use this same count to slice the pre-order array. And in step 6, we recursively build the left subtree using pre-order from pre-start plus 1 to pre-start plus left size, and in order from in start to root index minus 1. And in step 7, we recursively build the right subtree using pre-order from pre-start plus left size plus 1 to pre-end, and in order from root index plus 1 to in end. And in step 8, return the root. Let me show you the code. We start inside our public functions build tree. The very first thing we do is declare an unordered map called inorder map. We use this map to store the values of the in-order array as the key and their index positions as values. This let us find any root node positions. Next, we run a quick for loop. To fill up our map, we look at each number in the in-order array and link the number to its exact index I. With our lookup map ready, we call our private helper functions named build. We pass it our array, the starting and ending index bounding for both pre-order and in-order, and our map. The helper handles the heavy lifting and returns the final completed tree. Now let's look at our private helper functions. It tracks pre-start, pre-end to mark our active window inside the pre-order array, and in start and in end to mark the active window in order array. This is the base case. If starting pointer cross ending pointer, it means we need to run out the element to build node with. Our current window is empty, so we return null pointer. If our window is valid, we find the root. Reminder, the current root value is always at the beginning of our pre-order window. We take that value and instantly create a brand new tree node called root. We need to know how many nodes belongs to the left of this root and how many belongs to the right. We ask our map to give us the exact root index inside the in-order array. We calculate left size by subtracting our current in-order starting pointer int start from the root index. This tells us exactly how many elements live in the left subtree. Now we recursively build our left subtree. Looking at the new boundary math, in pre-order our left window start right after the root at pre-start plus 1 and goes up to pre-start plus left size. Next we recursively build our right subtree. In pre-order our right window picks up immediately after the left window at pre-start plus left size plus 1 and goes to very end. In order, our right window starts right after our root index at root index plus 1 and goes to the end. Now both subtrees are successfully wired up. to their parent. We return our root node back up to ladder, and that is the entire constructor algorithm. Its time complexity will be O(n). We visit each node exactly once. The unordered map gives us constant lookup, so total time is linear, and its space complexity is O(n). We store the in-order map with n entities plus the recursive stack, which can go up to O(n) in worst case. Let me submit this, and it passes. That is construct binary tree from pre-order and in-order traversal using recursion with HashMap for constant lookup. The key takeaway: pre-order give root, in-order give split. If you found this helpful, please like and subscribe. I'm Anand. Thanks for watching. I'll see you in the next problem.